The singleton pattern is the simplest design pattern of them all. The problem that the singleton tries to solve is cases where we have an object that we want to use widely throughout our system, but we don't want to have to pass an instance of that object to each place we want to use it. Also, it is often the case that we want to have only a single instance of an object. The singleton is a pattern, a creational pattern, that is designed to control exactly this type of use case. Let's take a look at the canonical example of the singleton design pattern. So here we have a client who wants to make a call on an object that is a singleton without calling its constructor, because it might already exist already. And remember before, one of the design goals of the singleton is to make sure that there's only one instance of an object. Also, we can see that the constructor is made private. That's what this minus sign is, as we recall from before. Right? So we can't actually call the constructor. Instead, what the client does is it calls this static method called getInstance, and that returns an instance of the singleton object. Now here, where getInstance, if you think about the implementation, where it gets the instance from is this field instance. And what really happens in this method is if this field is null, right, if the object hasn't been allocated before, it will go and call the private constructor. Because it's within its singleton itself, it'll set the field and it will return it. Now, one important caveat to be aware of with the singleton pattern is that there are some complications that arise here if you're using a multi-threaded language. So there's extra little steps that you'll have to take within getInstance to make sure that you're returning only one copy of this object. Now let's take a look at how the singleton can apply to our Mario game. So whenever Mario goes and jumps or gets hit or wants to fire, he needs to go and play a sound. So he wants access to the sound manager. But whenever enemies die, or if they bounce into specific things, or a coin gets collected, or a block explodes, they need to be able to play sounds too. So there are a lot of different types within the game that want the ability to play a sound. Now, one thing we could do is we could pass an instance of Sound Manager all around to all of these different types. But when you don't know which type is being created first, that might be tricky. The other thing with Sound Manager is we only want the sounds to be played by one instance of this object. So if two sounds come in at the same time, the Sound Manager will figure out how to deal with that. Right? So we want to make sure we only have one instance of this class. So the singleton really does make sense here. So what Mario does when he wants to play a sound is he's just going to say soundmanager.getInstance, and then he's going to play the sound. Singletons are often used by other design patterns as well, such as the Builder and Abstract Factory, although we won't be looking at those directly. Now there's a huge caution you should be aware of when you're thinking about using the singleton pattern. And that is that each singleton really is just a global variable. And we've known for a long time that global variables are just terrible. They're terrible from an evolutionary point of view, they're terrible from an understanding point of view, and they're terrible for really keeping track of what the state in our systems are. So if you find yourself spreading singletons throughout your design, you probably want to take a step back and really reason about whether or not those make sense. Another challenge with the singleton is that they rely on that static getInstance method. And statics are, again, another concern for designs, as they make your system harder to evolve as well. So when you start to spread statics around, you need to think about them. In this case, the role that static getInstance method plays is relatively limited and fixed. So we usually accept that as being an okay situation to use a static. One other problem with the singleton is that they really do also spread dependencies to singleton classes throughout your system. So if we think about the Sound Manager, right, every single class within the Mario game can play a sound, and that might not be what we actually want. And those dependencies will also be hidden within the code because they're never passed as parameters or set as fields. Finally, singletons make it a lot harder to test your code because we're not passing the objects around as parameters or setting them as fields, which would be easier for us to mock up or to set different stubs for. So this can be a real challenge when we're trying to design a comprehensive test suite in a system that uses a lot of singletons. Now, in the end, if your only solution is to use a global variable, the singleton might make sense. And if you need to be able to control the total number of instances of that variable, again, the singleton might be the thing to use for you. So I'm not trying to say never use a singleton, but when you do, really make sure that you're using it for the right reasons and you're thinking hard about whether or not having that global type is something that you're willing to endure.